Hi everyone. Today we'll be doing our second game, which is a lot more complicated than the one that we did last time. By a lot, I mean that we'll be using something new here as well, and in general, it looks more like a game because Hangman, we didn't draw anything. There were no things moving. It was more like a program that we did that was guessing letters. Nothing too complicated, but. The game that we'll be making today is this one. It's called Falling Rocks. So you are at the bottom in green, and let's call that this is a dwarf that is trying to evade some stones that are falling down to him, so rocks. And the idea is, to get in between the spaces and play as much as you can. So we'll be implementing here something that is going to be quite useful for future games and projects. So score, difficulty, so now like a real UI of the game, and as you can see it gets faster now that I'm on medium, and this is hard, so it gets a little bit harder as well. Right, so as you can see it's a lot more colorful, it looks better, and there is some action to it, and I'll be talking about something until I die, maybe. Okay. Try to think about. Okay, so yeah, I'm done. This is a good score. How much did I do last time? Do you remember? Was it something like 8,000 or 8,000? Okay, so yeah, that's probably my high score. Okay, so let's I'll start this and I'll stop it, and this doesn't work, so I have to do something else. So I'll do print screen there. I'll close it. I'll open up MS Paint. That's still available, and we'll be looking at it here, just so that we can see what we have to do and sort of analyze what we have to do and so on. Okay, maybe that's a bit too much. Okay, 100 then. Okay, so what do we have? So we have our player at the bottom. He can move left and right. We have some stones or rocks that are going down, and as they go down they change the color and the character as well. Okay, and what else do we have? We have these lines here, like a separator. We have the score, have some difficulty. The difficulty is, by the way, one of the easiest things to implement in this game, so it's nothing too complicated at this point. So right, and probably the hardest thing, what would you say is the hardest thing to implement in this game? The movement of the rocks. Okay, so first we have to generate them, and as you can see here we have 2, here we have 3. I'm not sure if this is on the same line, probably not, but there are different rocks, different number, different size, and so on, and also they are falling down, so they have to be generated maybe at the top here, and after that they have to be falling down. Okay, after that, when they reach here, this line, this last line, we probably have to check whether we've hit our dwarf. So this thing here is going to be our dwarf. I know that it doesn't look like one, but yeah, there is no way to do it in the console that I think of. So this is going to be our dwarf, and he's going to try to escape the rocks. Okay, so at the bottom here we need to check whether any of the stones have hit our dwarf, and also if they don't, we have to destroy them. Otherwise they are gonna keep going down, maybe go outside of the console, and we get an error or something like that. So when they reach the bottom and they haven't hit us, we have to destroy them as well. And I think that's pretty much it. So just as an explanation, as with any other game, we will try to structure our code and break it into smaller pieces so that we can find it a bit easier to implement. So I'll make a new project. New project. Not a blank solution at this point because it's just a single application. So making a game, and that is Falling Rocks. Alright, so let's get started with the usual stuff. But the logic that we're gonna follow, like in general as an approach or something like that, is gonna be very similar to one with Hangman. So we'll have comments and so on. We will try to fill in the gaps. So there, and we have Falling Rocks here with a capital, and I need to change that here. Okay, so let's break up the logic a bit. So first of all, we are gonna need some initialization logic. So I'll be numbering them this time. So initialization, is that correct? Initialization, maybe? Okay, so we have to initialize the dwarf, give it a color, maybe something like that. Maybe get a random number generator again, which we'll be using in this game a lot more, because the positions of the rocks are random, the number of rocks on each line are random, and so on. So we'll be using that a little bit more here. Okay, so this is like general initialization. Then we will have some dwarf initialization. Okay, after that we'll have our game loop, standard, same as the previous lecture. This game is a bit different though. So last game we were only inputting text on the console, which is something like normal, but here we actually have to control the character at the bottom. So okay, so here we have key handler. After we do that, we need to create some rocks. Create rocks. Move rocks down, as we said. And what else? We need to check for collisions once we've moved them down. So check for collisions. Then we have to. I've separated the logic so that the printing is at the bottom. So print dwarf, and we have to clear the last row. So all of this is just some UI elements. We have to draw the vertical lines, and by that I mean these lines here. Okay, this is pretty simple as well. Okay, what else? We have to draw the square, and I'm missing something because so clear last row should be okay. So here I have to print rocks. Now this is going to be 10. It's going to be 11, this is going to be 12. Here we'll have draw square, and maybe at the end set difficulty. Okay, is there anything else? And finally the game over logic. Game over logic. Okay, as I mentioned a couple of minutes ago, there are many ways to make a game, and this case is not an exception. So let's just analyze this a bit more. So first of all, all of this here, which is our playfield, we can think of it as a matrix, or another word for it is two-dimensional array. This is something that we haven't done for now, but if you find it hard, just imagine an Excel table, and what I'm actually gonna do is just open up Excel, if I have one here. Okay, and so this is what we are gonna use. So we have you know, a table with cells. Maybe this is our playfield here, and you know, rocks are coming in at the top. We have our player at the bottom. So player, let me just make it so that you can see a little bit better. Okay, interesting. Okay, so this is our player. We can move him left and right, and you know, here is a rock, here is a rock, rock, and so on. And so this is done in a what is called two-dimensional array, or a matrix. And every time when I say that, you just think about this table. So this table has coordinates for each cell. Say if I want to access this one, it has an address which is called B2 in this case. So have every one of you like know Excel and have worked with it, I hope? Yes? No? Okay, yeah. And right, so this is pretty much the same thing that we'll be doing, but instead of having a letter here to address the columns and a number for the columns, we'll be using just numbers. So if I want to access this specific cell, it will be, you know, cell which will have coordinates 2 and 2. And if I want to access this one, the first number tells us the number of rows. So if I want to access this one, it's going to be cell of 2 and then 4. So the first number gives you the rows, the second number gives you the columns. And this can be a bit problematic and confusing, because when you're working with a standard mathematical coordinate system, it's the other way around. So this is x, this is y. So you know, when I give a point here, or let's just say somewhere around here, this point is going to be 3 1. Let's just say that it's 3 1. So this is 3 here, this is 1 here. And if you notice, we first give the horizontal element, which is the x, or 3 in this case. But when you think about it in terms of matrices, we would have to first give it the other way around. So first we need to give the row, meaning how high it is, and after that we'll need to give the column. So it works the other way around, and it can be a little bit confusing, but hopefully I'll tell you when that happens, and we'll be able to work it out as we go. Okay, so right, and another thing that I want to say about what we are going to be doing. So this game, of course, I can make a table with, you know, these symbols here. So I can make a table with characters, right? And you know, draw them and change colors and so on. But I've come up with a better method, I think, which is you know, you don't really need to optimize the game like this, but I believe it's gonna work faster, and I believe it's a nice way to think about it. Feel free to do it with a character array at home. But what we are gonna be doing is in our array, which is, you know, gonna be given like this, we will only have zeros and ones. So it's gonna be int. And the notation for that is this way. So square bracket, comma, square bracket, which means that we'll have two coordinates, one for the rows and one for the columns. And what I'll be doing is just putting zeros and ones there. So if it's 0, this means that this cell is empty. So cell is empty. And if I have ones, this is going to mean that we have rocks there. Okay, this doesn't mean that I'll have zeros and ones falling. It only means that I can go through this table, see if there is a 1, just draw a random character or something like that. So I believe this is a lot easier to keep track of and work with and so on, because when you have characters it can be a little bit confusing as well. Is it clear what we are gonna do? So instead of having the characters falling down, I'm gonna have zeros, which mean empty space, and I'll be having ones, which mean that there is a rock of some type there. And we'll be working with zeros and ones because it's a lot easier as well. Right, if I want to optimize it even more, this int can be byte, right? Just not to take memory, because I will only be using zeros and ones. I won't have any numbers from -2 billion up to 2 billion, so I can use byte as well. But we'll see. We'll start with int, and then probably once the game is finished we can change it later. But the operations are pretty much the same. Okay, any questions about what we want to do? Are you clear on like the rules, the game? I've played it a couple of times maybe in the lecture, because it's fun. So I've really tried to balance it. So right now I work as a game designer, and balancing is a part of my job. So I tried to balance it right then and there when I was writing this code, so that the easy is easy, the medium is medium, and the hard gets you killed after some point. Right, so everything is clear on the game. I'm gonna die on purpose. Okay. Right. Okay, any questions? No? Nobody. Okay, so let's get going. So first we'll need to initialize some things that will help us. So first of all, I would like to have the random number generator that is gonna be useful later on. Okay, after that, I want to do the multi-dimensional array, or two-dimensional array, which I'll be just calling matrix from now on, because those are long words. So I'll have a matrix of integers, and this comma here means that it's going to be two-dimensional. If I put another comma here, it will be three-dimensional. And if you remember last time we did a simple array of characters, which was for our word in Hangman, and this is very similar. Instead of having so yeah, let me just draw that, because we haven't done this yet and some of you may be confused. So we have a box, okay, and let's say that this is a variable of type int, so int a. An array, which we did last time with our word, character, which was word. Okay, we had many cells, which are all of them were separate cells as this one. So this one was a single cell, the second one was also, the third one was also, and so on. And what we're doing today is just expanding a bit more into a two-dimensional array, or a matrix. This was amazing line. And yeah, so we have cells which all of them are of the type int in our case, and the way to write this is just with a comma. Okay, so let's get back to writing some code. So int, I'll be having this, and I'll call this rock positions. Okay, clearly because it tells us where the rocks are. If you have a 1, this means that at this specific cell we have a rock. If it's 0, then it's empty and we don't do anything to it. Okay, and new int, the way you initialize is we haven't done that yet, but we've done the keyword new, so that should give you some clue of what we're doing. I would like to have an array which has a specified number of cells, so a specified number of rows and a specified number of columns. And the way to define that is just to put these numbers here. So we have 30 columns and 30 rows and 45 columns. Okay, and I know this because I've done the game. Clearly you can see it, and I would not like to test like with different numbers and so on, at least not at this point. Okay, then if you remember, if I do something like just to show you what the next line is going to be about. Come on, honey. I believe in you. Right, so you see this thing on the right, which you probably cannot see. So this thing is called a buffer. Can I? Okay. And we don't want that, right? So this thing here on the right, we don't want it to be able to move and so on, because the rocks are going to be falling down and we are not going to be able to focus on our character and so on. So we have to define our play field, or the box in which we have the rocks and the player and the difficulties and so on. So this is something that you always do. So even if you're making the next RPG or something like that, you have to do a resolution at the beginning. So you have to say, I want my game to be full HD, or if I'm making a mobile game, it doesn't really matter that much if it's full HD or not. I'll just make it just HD or something smaller even. So this is what the next lines are for. I don't want to have this buffer on the right, and just to define the resolution of our game. So console.bufferHeight equals console.windowHeight, and that equals 30. Okay, so if you're completely honest, this is a bad line of code. Do you know do you know what this line of code is going to do? Right, anyone, just anyone, what this line of code is going to do? How is it executed? Is it yeah? So yeah, this is correct. So it's not evaluated from left to right. So this equality is actually last. So I'm giving the value 30 to console.windowHeight. Okay, now this is evaluated first, and then after that I give the buffer height. I give the same value, which is this one, which is 30. So it works the other way around. And now have something similar for buffer width equals console.window width. Okay, which is going to be 60. And okay, it works. Right, and if you've noticed, this is our window, and this is what we've defined now. So this is, sorry, I have to be writing probably. So this is now 30, and this whole thing is 60. Okay, out of it, I'll only be using this one for my play field, and this bit is 40 down there. Okay, so we need to have a number for our play field as well. So right, play field equals 40, and that's pretty much everything that we're gonna need for the general initialization. Let's do the dwarf. It's a bit more interesting. So int dwarf x equals 20. So we want to give a initial position of our dwarf, which is going to be here in the middle. Okay, can anyone tell me straight off that, why is this line of code not good in terms of quality code and how we should be writing our code? Exactly. If I change the play field, I would have to go to my dwarf and change that as well, and I don't want to do that. So instead of doing that, I would like to just put something which has the play field already in. So I want it to be at half the space, and to do that, I don't have to give hard-coded values. So this thing here is going to be play field divided by 2. Okay, and this is better. So now if I decide to make this 50, then my dwarf is still going to be in the middle. And remember to do this as like if you're working on larger project or something like this. So these numbers are called magical numbers that I'm putting in right here. But because the game is small, I'm not going to put them all as constants. But it's very good to have constants at the beginning. So say that, you know, int play field width equals, you know, 45 or something like that. So that if I use all of these in my code, after that I can just change the whole game in a matter of changing a couple of numbers. Whereas if I do it this way, if I just put 20 here, as soon as I change one value, I have to change it everywhere else. So just try to use constants as much as you can, but in this case I think it's an overkill. So we'll only be doing that where we can, so that we don't, you know, overdo it. Play field divided by 2. Okay, and right, what else do we have for our dwarf? We also have the y position. So dwarf y equals, and I want to have it at the bottom here. If you can see, I want to have it at the very bottom. So instead of just putting there, you know, what was it? Was it 30? Yeah. Instead of doing that, I'll just do console dot window height, and I have to do -1 because otherwise, you know, it's gonna get out of the screen, because we start working from 0. So whenever I say new int with 30 elements, they are going to start from 0. So my 30th element is going to be rock positions of 29. And in fact, I cannot access the 30th one, and I'll get an error. So this is why we do the -1 here. And what else? We have to have the symbol. So string dwarf symbol is, let's make it the same as in the game, but I can change that later and it will work fine. So it's going to be this one, and of course we have to set the color. What was that? Okay, and also we have to do the color as well, which in this case is green. So I'll do that. Console color, and we're gonna have this as dwarf color equals console color dot green. And now our dwarf is gonna be green. So if I wanna change him afterwards, I can just choose any of these, and it's still gonna work. Dark yellow, magenta, gray, and so on. I can make it black so that this is, you know, impossible to play, but let's stick with green because, you know, you can see it well. Alright, that's pretty much it for the dwarf, and I've put it in the wrong place. Okay. Okay, game loop. Yes.
If our play field is 40 pixels, why do we have 45 columns on rock positions?
Sorry, I don't get your point. Can you repeat?
It is 40 squares long.
Yes.
Why do we have 45 columns in the rock positions?
Okay, so our play field is let me just draw. So this thing is 45, and I'm leaving 15 here for my UI. Was that your question? Did I answer it or not?
Yes, we have 45 positions for the rocks.
Yes.
Yes, then why is our play field 40?
Is it 40?
Yeah.
1 second. Playfield 40. I don't know, it could be 45. Let me check. Okay, here it says 40, but I'll make a note here because I don't want to break the code right now. So bug detection, try 45. Okay, maybe I've put here some extra. Sometimes, especially when I was starting now and when I was doing this game, maybe I've tried to test something out and I left it there as 40 or something like that. But we'll try. So to do, I'll put that here. Okay. Yeah, it's a good point. I did not see this. Okay. For the game loop, we'll need a couple of more things. So for score, and the score that you see at the top right here, we're gonna be doing that based on the timer. So the more you play, the higher score you get. There was another idea earlier, which was to increase it with the number of rocks falling, which is also fine and it's easy to implement, but you know, whatever you choose. Okay. Right, so score, and I'm gonna start. So this is a stopwatch. So we did something like this on the workshop. So I'll use another function which creates the stopwatch and starts it straight away. So stopwatch. I don't have it here, so control dot and enter, and now we have this thing here at the top. Okay, so stopwatch dot start new. Okay, and it's gonna make it and it's gonna start it at the same time. So you don't need to do first initialize it, then start it, then stop it, and so on. If you see here, there is no here. It doesn't stop. It just goes on. So there is no need for me to do that separately. Okay. By the way, can you all see it from there? Can I try to make it, you know, larger? No, probably not. Okay, sorry that it's so tiny, but yeah, I hope you can see well. Okay, maybe if yeah, maybe I should do that. I did that. Oh, come on, you just start. Oh yeah, I had to. Okay, right now we don't have anything, so yeah. Yeah, I can try that, but I've closed it, so let me just go through it again. I don't know if it's gonna work here, but you know, let me try. So properties, and then I would like this, and then I would like a large font. Okay, is that better? Let's see if I close it and start it again. Okay, so this is a lot better, I guess. Has anyone not understood what the game is about because it was too small, you know, tiny? And the back? No? Okay. Okay, so we are gonna need this stopwatch, and it's probably good in terms of logic to just put it there. So this is in the general initialization field, so I'll leave it there. And under the game loop, I have a couple of more that I need. So bool is game over, and we're gonna start this with false. So it's very similar to what we did with the Hangman game. And what else? And then we can just start our loop straight away. So game loop while is game over, and we want that to not be true, right? We want the game not to be over, and at some point I'm just gonna say, you know, game over equals true, and we're not gonna get into that while loop again. Okay, and I have to do this probably. Yeah. Okay, so let's do the key handler. I don't think we did something similar, but I think I've showed it on the lectures on console input output. But you know, we'll be doing something a bit more different so that it can work. Okay, so how to do that? If console.key available is true, meaning if I've pressed the key, I wanna check that I've pressed it. Okay, so console key info was the data type that was holding the information about the pressed key. We did that in a lecture. I'll call this pressed key, and that is console.read key and I'll put a value here true, which you should not worry about too much. And I'll put another line which is going to be a hack, and I'll tell you what it does. Key available. Okay, so I'll say it straight up here. This is a hack. Okay, so if I didn't have this line and this one instead, if I was just reading a key from the console, it might have read it in between frames, and also if I hold down on a button a little bit more, it would have read it many times the same number. Okay, so this is what this while does. Every time that we press and hold a key, it's gonna read it, and not just read it once and stuck and just assume that we've pressed it many times and waits to actually execute it. So this is a hack for better controls. And once we have the game, I'll delete these lines of code, and I'll just put as to do here as well. I'll delete these lines of code, and we'll see what is changing. I mean, you probably wouldn't be able to see, but if you wanna come and test it out, you will definitely feel the difference. Okay. Right, and after that, I need to check whether I've pressed left or right. So if pressed key dot key, this gives me the key that I've pressed, equals console key dot, and here console key dot is a separate class, and here I have all of the keys in a keyboard. So right now I would like to do this first for the left arrow key. Okay, and what is gonna happen when we press left arrow key? We wanna move our character to the left. Okay, so remember our dwarf had so this is 40, the whole of it. My character was at 20, and this was the dwarf X variable, which was showing me where my dwarf is on the horizontal last line of the game. So what do you say has to happen here? Decrease the X variable. So if I just do that, so let's do that, dwarf X minus equals 1. So if I do it with 1, it's going to be very slow because I've tested it. So I would like to put this as 2, meaning that every time it's going to move to positions to the left or right if you press the right key. Okay, but here there is a problem. Can anyone tell me what the problem is here?
If you want to move just off it one, you can.
Oh yeah, of course. We can't go out of the box, so we also need to check. So check whether have you written this game before? Check whether we've left the box. Okay, so I need an if statement here, and that's gonna be the following. Okay, if dwarf X minus 1 is bigger than or equal to 0. The reason why I have minus 1 here is because I actually have 3 symbols for my string. Okay, and yeah, so this is how I check. I want to check if I am 1 to the right of my playfield, then I can keep left. If not, if I'm here at the minus 1, sorry, if my position is actually equal to 0, I cannot move left anymore, or I'll be going out of the playfield. So basically it says if I am right here, I cannot go on more. I cannot press it more. Okay. Right. So let's do the other one as well. else if, and here I want to have pretty much the same thing. Pressed key dot key equals console key dot right arrow. Okay, and inside here pretty much the same thing, but I have to keep in mind the play field as well. So if dwarf x plus 3, this is again because of the three symbols here. If dwarf x plus 3 is less than play field, only then I can move. And dwarf x, how should I write this? If I want to move right, what do I do to my dwarf x? Sorry? Plus equals 2. Okay, that's pretty much it for my movement. I really want to check right now whether what we are doing is, fine. So let me just clear the console at the beginning. Console.clear, because we have to clear it at every step. I'll actually show you what happens if we don't have this. Console.clear. But so this is the movement, but we are not printing our dwarf anywhere. So that's what I want to do, just to see whether what we're doing is on the right track. So right, so here console.set cursor position is what we will be using. So if you notice at each step, so let me zoom. At each step, I have to draw here, I have to draw here, 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 and so on, just everywhere on the console. And if you remember, if I just open up some console there, I normally cannot do that, right? It starts wherever it says, and I can't control that from here. So I have to tell the cursor, or this blinking thing here, I have to tell the position where I want it to be before I draw something. So let's do that. So I would like to have set cursor position to the dwarf x and dwarf y, because these are the coordinates of my dwarf and I want to draw it there. Okay, then after that, console, I do not have the semicolon here. Console dot foreground color. I would like that to be dwarf color. Yes, thank you. Dwarf color. All right, and finally, I just want to print it. So console right without the line. Dwarf symbol. Okay, shall we start this? See what's going on. Oh, come on. I have an error and I have no idea. The value must be less than the console current max size of 27 in that dimension. Actual value was 30. And why is it 27 when I was giving it a solid 30? Let me just, so yeah, okay, I want to check something here, whether that is going to fix it. Yeah, so that fixed it. So the problem was that I had a very big font, and it couldn't print all of the lines in one screen. So right now, this is what happens, and this is what happens when I don't clear the console, but we can see that we can move freely, left and right. You can only see just a couple of things changing, and mainly the cursor there, but it works. Okay, so let's experiment a little bit on that before the break. So console clear is what now is gonna make it so that I can not see all of my moves, and it feels like we're moving. But in fact, every time it's clearing the console and it's drawing a new one. Okay, but this thing blinks very weirdly and you can barely see it. So can you tell me why that is so? I should put some sleep time, yeah. So thread dot, okay, so I need to have that as well. Control dot, enter, and now we have the system dot threading. Okay, thread dot sleep, and let's say 250 there. Okay, now it feels a lot better, doesn't it? So now, so I am pressing the buttons every time now, and if I want to hold, it's gonna still work. When I stop, it's gonna stop. And if I remove any of these lines that I've written above, it's gonna behave weirdly. So let's say that I delete this, and now if I'm pressing, if I stop, it keeps moving, right? It keeps moving for a couple of seconds, and now I can't even move it because it read so many comments to the right that it just doesn't want to stop. So right now I'm not pressing anything at all, and it's gonna start moving right any second now, I guess. I hope. So yeah, right now I'm not pressing anything because the program read the right key many times, and it didn't free up space for when I don't press it and so on. So this is why we have this while loop here. Did you understand the hack that I did? Okay, so just remember this. So this is one of the things that if you don't like search on Google or something, you wouldn't be able to know. So if you type something like controls not working in console, or they're slow or buggy or something like that, you will definitely see this. But yeah, so the idea here is that I am reading the key as long as there is a key available for me, and this way I can ensure that if I stop pressing it, if I stop pressing a button, it wouldn't be remaining in some buffer array of commands keys that I've pressed. Okay, but yeah, if you don't want to think about it too much, just remember pretty much this line of code, because this one above is just standard reading a key. And what else do I want to change? So how would I change the difficulty, and why did I put the thread.sleep here into the set difficulty? Just make it smaller, and it's gonna work, and that is fine. Okay, I suggest that we have a short break, and we'll be going on to the other stuff shortly. Okay, so we have our dwarf, and it moves left and right. Hopefully if this thing starts a bit quicker. Yeah, so we can move. If I hold and I stop, it stops with me. If I hold and stop, it's gonna stop as soon as I press it. Okay, the next thing that we'll be doing is creating the rocks. So creating and moving, so these three are probably the hardest in this game, but once you see the code, I hope that it's going to be fairly simple to do. Okay, right, so create rocks. The way to do this is we just need to go back to our matrix, which is this one, and I want to place ones where I want to have a rock at the very top. So I'm only placing rocks. Just 1 second, let me zoom in. So I'm only placing rocks here, so it's only ones, and after that I move them down. Okay, I don't need to place them everywhere around the playfield, because otherwise I wouldn't be able to play. So I need to just create them once here at each step, and I want to move them down as well at each step, and this is how it is going to work. So okay, let's create them. So let's start using our RNG. So int number of rocks. If you saw, we had a different number of rocks. They could be a single rock, a double, or a triple, or if you wanna, you can make it larger as well. We'll see if we can experiment with it as well. So this is rng.next. We used that method last time, so I want to have that from 1 to 3. Okay, I don't want to have or maybe 4. Just 1 second. Yeah, right now it doesn't work. I wanted to start this. So here I have 3 as well. So 1, 2, or 3. Let's just leave it with 3. Oh yeah, I know why this happens. Okay, so let's put 4 and let's see what happens. If we don't like it, we'll just change it. So right. Okay, so we have the number of rocks that we want to put, and after that I'll need a for loop to place each one of them, right? So for I from 0 to less than number of rocks, I wanna have also different rock lengths. So just 1 second, let me put that here as well. So number of rocks. Can I stop this now? No, I can't. So let's just go back here. So there are two random things going on here at the same time. So I have a different number of rocks on each row. So on this one I have 2 of them, which is what we did now. And they can also have a random number of elements, which in this case is 2, in this case is 3. Here we have 1, and so on. So here we would like to use the RNG twice. Okay, let's get back. So here I want to have rock length, which is going to be rng.next, and I want to have them between, let's do it between 1 and 3 again. Okay, if I put a 0 here, then I'm not going to generate a rock, so there is no point in doing that. So I want to either to be 1, 2, or 3 for the rock length. Okay, and now for each rock and each rock length, oh yeah, one more thing. So I need also the position of the rock, which is going to be rng.next, and my playfield is from 1 to 40. So I'll be doing that, just 1 second, maybe from 0 as well. Yes, from 0 to 40, because now it can be on the furthest left, so that is fine. Okay, so from 0 to 40. 40, the playfield is 40, and we said that we are gonna probably change either this or this depending on what happens. So in my code I have this value as 40, and I don't want to change it now. We'll just change it later and see what happens. And I have my to do here, so I'm not gonna forget. From 0 to playfield, very good. So yeah, this is what we have to do, from 0 to playfield, so that I don't have to get back and change it again. Okay, and now for each rock, which is here, so at each step of this for, I'll be generating a single rock, which is going to have some length. So for each rock, I would like to have another for loop here, which is going to be filled with j's, and I want it to be rock length. So here I am getting a rock, I am getting the length, and you know I have to print it every time, right? I want to say if my rock length is 3 here, I have to print it 3 times, and this is what my for loop is here for. Okay, and what did we say that we want to do? Rock positions, this thing of 0. I want to create them at the very top. So if you remember, this value showed me the number of rows, and I want to generate it on the very first row, which has index 0. And then after that I want to use my position x, and I want to add the j here. So why do I add it? So let's take a look back here. So if I have something larger, like this thing here, it has 3 symbols, right? So if j is 0, I'll put the first one. When j is 1, I have to put the second one, and if j is 3, I have to put the third one. So let's have a look at this. Let's say that this is position, I don't know, maybe something like 15. Okay, and I want to place the first one at position 15, which is going to be 15 plus 0. The second one is going to be 15 plus 1, and the third one is going to be 15 plus 2. Okay, and these are the j's. So these are the j's that go from 0 to, you know, in this case from 0 to 2, right? This is my also known as rock length that I've given. Is it clear what these 2 for loops are doing right here? This one and this one. If anyone thinks that it's not clear, please just raise your hand. It's fine. I can just say it again. Don't worry if you haven't understood that. Okay, I'll just keep going. Okay, so now I said that we'll have an array of ints, and the only thing that it's gonna show us is whether we have a rock or not at the current position, which is gonna be seen whether we put 1 or 0. So here I want to put a 1 because if we have a rock at this position, then I wanna just get 1. This means that at this specific place there is a rock. And okay, I think that's pretty much it. Okay, moving rocks down is the next step, and it's not that complicated. I think it's very similar. So we have to go through every single. So let me just type it here. So just as a comment, go through every single cell. If it is a 1, move it down and delete the previous position. Okay, what I mean by this is let's say that we have our playfield. There was a way to do lines here, but I don't know what that is at the moment. So right, so shift, is it shift? Thank you. Okay, very nice. So there and there. I think that is pretty much enough. Okay, so now let's say that I have a 1 here that I've generated a rock, and I want to move it down, right? So this is done in 2 steps. So first of all, I have to put it down clearly, and after that I have to go back to this one and just change that to 0 because there is no more there is no longer a rock there. And it's pretty much as simple as that. Okay, so for I equals from 29, so for some reason I decided to do this backwards, and I don't know why at this point. I guess we'll understand once we do this. So from 29 to 0, and I want to decrease. So this is I start with 29. This is my initial value, and then I want to iterate over this for loop until I get to 0, and at each step I want to decrease the i's. Okay, and then the same thing for the j's, but for some reason this is now in the right way. So less than playfield. I would like to put 40 there, but it's fine. Okay, so if rock positions equals of ij equals 1, then there are two things that I want to do. So first of all, I want to have rock positions of ij to be 0, right? I wanna delete the rock from its previous place, and I also wanna move it down. So I plus 1, and then j equals 1. Okay, is that fine? And now I know why the reason for me starting from 29 to from 29 going back to 0, which I'll explain in a second. So let me just refactor this to row, and let me refactor this to column so that it's a bit easier to read. And I want to do that same thing here, row, and then col. That's not okay. Yeah, that's not it. So yeah, I should be doing that. Okay. So can you guess why I'm starting from 29 here and going downwards? Um, sorry. Okay, so the reason is that if we start at the top, so let me just okay, so yeah, there was the shifting. So just these. Okay, so if I start, so let's say that I have a 1 here and a 1 here at the same time, and I want to move them down. So if I start with row from 0, which is, you know, this one, I want to move this down, which is going to overwrite this tile here, and I'm not going to have it anymore. After that, when I get to this, I'm not going to have it. I'm not going to be able to move it because I've deleted it, right? And actually this way, so because I go from rows from 0 to, you know, 40 something, was it 40, or let's just say that it's okay, 30. Right, so let's take this 1, and I want to go through every single cell and move it down. So at the first step, when I'm in this row, I'll take this 1 and I'll put it down here. In the same for loop, when row gets 1, gets 1, I'll be moving that down again. And what is going to happen is that after the first step, this tile would have gone to the end, just straight away. We wouldn't be seeing it move step by step because I delete it, I put it here every time, and in the next iteration of the loop, I'll be putting it down again, and so on. So this is something that you have to take in mind. So if something is not working, maybe you should just debug and see, you know, what is wrong. So in this case, let's pretend that I knew this from the beginning, but at some point I was bashing my head with it, and I came up with it with this. So if you do it the other way around, so if you start from bottom to top, if I have a 1 here, and this is, you know, row 28, I'll be moving it down here. I'll get a 1 here, I'll get a 0 here, and now if I have something above it, it's gonna move on its place without, you know, deleting anything. Okay, was that sufficiently clear? Was it fine, or did I get someone confused? Nope, I think it's okay. Alright, we're pretty much done with this. So moving the rocks down, it's not too complicated, just, you know, change the next one to 1 and change the previous one to 0. Okay, and after that we would like to check for collisions. Okay, for this I am going to need a boolean. Is there collision? And int counter equals 0. We're going to use that a little bit later. So for, and here I would like to have row from 0 to playfield. So we'll be going through all of the rows, and we are going to be checking whether our dwarf is at a position where there is a 1 in our matrix of zeros and ones. Okay, and okay, so from here I would like to have if, and this is going to be a long if. It's going to check whether our rocks have hit the dwarf. So if rock positions of 29, which is the last row of my table, and then I, which is actually the column. Thank you. Okay, so 29 is the last row, and I'm going through every single cell, seeing that if it's a 0 or a 1. And if that equals to 1, and call, thank you. And also I want to check now whether my dwarf is at this specific position. So how do I do that? If dwarf x equals row, is that gonna work? What do you think? Call. Okay, that's definitely not gonna work with the row, but with call. Okay, so yes, so our dwarf, which is right here somewhere there, we have three characters reserved for it, and if I only do this that I've just done with the dwarf x, we are gonna get a collision only with this single bracket here, and I want to have all of them. So let's see, we were down here. Okay, and what do I need to do also? I have to put this in brackets because I want this to be true and this whole thing, which is a separate condition, to be true as well. Okay, or so either we've hit the first bracket, which is, and let me just, so dwarf symbol is, and we need to check 3 positions. Okay, and then my next is if dwarf x plus 1 equals call, or dwarf x plus 2 equals call with 2 times equals. Okay, now if I close the bracket here and something happened, I don't know what. Okay, right, and now this should be fine. So if this thing happens, I would like to say that there is a collision. So is there collision? Okay, but instead I'll be just doing counter plus plus, and I will be dealing with this boolean a little bit later on. The reason I do this, I would like to separate my logic later with methods, and if I use this here, I won't be able to do it as smoothly as I want to. Okay, so another thing that you can do here is, you see this if now is a bit big, right? So what I would normally do is bool has dwarf been hit, and here I would put all of this. So, and then semicolon in the end, and here has dwarf being hit. Okay, and that's pretty much the same, but now this is a lot easier to read. Okay, so if we have a 1, meaning if we have a rock, and the dwarf has been hit, then you know, we would like to do something with it. Okay, so going on, now I actually wanna change this boolean. So if counter equals 0, this means that is there collision is false, and else is there collision is gonna be true. It's true. I could have done it here as well, but as I said, I want to just separate my logic a little bit more. Okay, right, so we've printed our dwarf. This is pretty much all there is for the checking for collision. We are basically taking use of the easy check here with a 1. If it was a character, you would have had to check for every single sign whether it's in there or if it's empty, or you know. So this is a lot easier in terms of checking. It's either 0, which means it's empty, or it's 1, which means it's that there is a rock there. Okay. Right. What else? So we want to print the rocks now, and this is very simple. So now from 8 up to 12, this is pretty much now on the UI. So we want to just draw different things. Now we have the main logic of the game, and yeah, so this is the UI here. Okay, right, so we need for this is row from 0 to 30, and for column is from, this is playfield, and it's very simple. So I want to print only if I have a 1. Okay, so if I don't have a 1 at a specific position, then I don't want to print anything, so I won't have to do anything there. So if rock positions of row and column, so if a specific cell in my matrix is a 1, only then I want to print it. Okay, and right, so what do I want to do? I want to set the console position, set cursor position. I want to set it to J and then I, so col and then row. And the reason for this is that this method takes the arguments in the reverse way, and this is just done by checking. So let me put here to do check with reversed col and row. So you would think that first you have to put the row and then the column, but it doesn't work this way, and I've done this with checking, so it's the other way around. It's like what we said was the, sorry, one second. It's like what we said with the coordinate system, where this is the x, this is the y, and xy. So this method, which is set cursor position, actually takes these x and y, and it doesn't take the row and the col that you would see from a matrix. So here are rows and here are columns. So yeah, I know it's a bit confusing, I know, but you just have to test and get used to it. So once you try here with a row and a column, so if I change this, and if you play it, your rocks are gonna move from right to left, right, which is not what we want, and clearly you have to change this line. So this is done by testing. So col and then row. Okay, here comes something a bit more interesting. So console.foreground color equals, and now I have to put a random color, right? Because at each step, not here, at each step here I have a random color coming up. Okay, and let me just play this. Can I? Oh yeah, I was confused. So if you see, if you just spot just one rock and follow it down, it changes both the color and the sign. Right? So as soon as I'm printing it, I would like to have something that gives me a random color. Okay? And this is going to be a method. So I'm going to write here randomize color. And I want to put in here the RNG that I already have. So I have my RNG here. It's really bad practice if you have more than one. Say here, I don't know if I've mentioned this, have I? So if I put here random RNG2 equals new random, the values that RNG and RNG2 are gonna give me are the same, because they're initialized in the same millisecond. So their seed, which is used to get the random number, is the same, and they will give you the same value. So I don't have to initialize it twice. I just need it once. And I want to give this random number generator to my function here, which is going to use it just straight away. So control dot. So here that I've put a name for my method. You know, it might be hard, and we are still not at this lecture for methods, but it's very, very easy. So I press control dot, and here, if you see, it tells me generate method falling rocks randomized color. So if I press enter there, it's gonna generate it automatically for me. And there we go. And now if I scroll down, there it is. It's everything that we need to, you know, just get started with our code. And this method is going to be fairly straightforward and simple. So let me have it here. Okay, we have the random, and so I want to choose a random color from an array of colors. So it's let me just do that again. So instead of having an array of integers that we had, okay, I want to have an array of colors. And here is say green, so I can probably do that as well. Here is green, here is red, here is yellow, here is orange, and so on. And I just want to choose a random for them. So I have to do, say, I have 4 here. Let's say the therefore. I would like to get rng.next of from 0 up to 5, and this is going to give me a random color, which I don't have to get back as a value. Okay, so nothing that complicated that I'll be doing here. So console color. So this is an array of colors, and the type of a color for the console is this. So console color colors equals and I'll just define my array this way. So now I just have to put some colors here. So console color dot let's say blue, console color dot I have cyan here. Let's put some more. Console color dot what else? I have yellow. Okay, yellow. I have to put the comma. I think commas should be at the top, but I'm not really sure. So let's just put them there. Console color dot magenta. I can have white as well. Okay, anything else that you want to have? I have red here as well. Do you want red?
Orange.
Console color. Let's see if they have orange. Orange is my favorite color, and they don't have it, which is a shame. Someone said purple. No. Yeah, let's just choose one. Sorry? Yes, I think it is. Purplish. Here it says. Right. Can you read this? Purplish red. Whatever that means. Okay, yeah. So let's just choose one from here. Maybe we can make a black bomb that you just, you know, randomly die. Let's put a dark green with dark yellow. Okay, dark yellow is fine. It's gonna be harder to spot, you know, make it harder. Okay, so this is my array of colors, and I just wanna pick one at random. So random color number equals rng.next, and I want to have it from 0 up to colors.length. And let's be consistent, which is gonna mean that I have to change it in many places. So I'll just keep to the American way of writing. So there. Okay, and now that we have our color, I have to bring it back. So I've chosen it, and I have to bring it back so that my method, which is here, can use it. So I have to give this console.foreground color, I have to give it a value which is of type color. And the way to do this, and don't worry if you don't understand this, there will be a separate lecture for it. I have to do return colors of random color number, and that's pretty much it. I just have to, you know, return it, bring it back to the place that I've used it. So here. Okay, and furthermore, I would like to have console. What did I want to have? Just give me 1 second. I have to get the symbols. Just 1 second. Let me find it. It's pretty much the same, yes. So console.write, and I just wanna give the random or randomize rock symbol, and I would like to give it the RNG as well. Okay, and I don't have this method, and I just press control dot and then enter if it appears. There we go. Now if I scroll down, here is my method, you know, ready to work for us. And here I have object, but in fact I know that I would like to do a character or a string. What do you say? I probably want character, don't I? Yes. Char. Okay, and it's pretty much the same. So I would like to have a an array of symbols. So symbols or rock symbols, and those are gonna be, you know, just some random symbols. Comma, comma. Let's see. Here I have the A, I have the star, I have the, yeah, I have to change it. I have the star, I have the end, I have plus. Anything else that you want to see here? Minus, equals, percentage, dot. Dot is cool. What else? Do we want to make a 0? Or if I could, I would do this, you know, just to be killed by your own friend, which who is, you know, falling down. It's not nice. Okay, I have the dollar sign here. Someone said slash. Okay, slash. Is this gonna work now? I don't know. Yeah. Okay. Exclamation mark, question mark. It doesn't matter. Here you can put anything that you want, pretty much. Sorry? You can put the whole alphabet and beyond. I can even put something like, probably, I don't know. We'll try something like this. Why I wanted to print something else, so let me just.
Random Unicode code.
Okay, where is my je? There it is. Okay. Let's see if that's gonna show it at all, or it's gonna be just a question mark. For this, I want to check. I'm just gonna delete this. Okay, and int, pretty much, yeah. Why not? Int random rock symbol. I'm sorry, random rock number is rng.next, and I want to have that from 0 to rock symbols.length. Okay, and the same as the previous one, I just want to return rock symbols of random rock number, and that's pretty much it, right? Yeah. Okay. For this method, are there any questions on those two methods? I'm sure there are. Like, I will tell you straight away, don't care about this private, don't care about this static, don't care about this at all. The only thing that we are looking at is that I am taking a part of the code that I could originally put here as well in some form, but instead I'll just, we want to separate it because looks better, just to have this randomized color instead of all of these things that if someone is reading all of your code, they may get confused. So here, this means this first type here says what I need to return, or what I want to bring back from my method. And this is the name of the method, and this is what I want to give to my method that I want to use inside it. So I have an RNG already, and I want to give it to the method so that I can use it inside. And if you can see, I have here, I don't have anywhere random RNG equals new random and so on. I don't have this because I have given it to my method here, and I can use it straight away inside here. So I don't need to declare it, and I don't need to because I already have it at the top of my code. Okay, and then that's pretty much it. So this is what we return, this is what we need in our method, this is the name of the method, and at the bottom just return whatever you want to bring back. If I just, okay, so this is for another lecture, so I'm not going to go into detail. So here I want to give back a color. Still I would need my RNG, and it's pretty much the same. At the end I just bring back my color to the method. Okay, we are up to where? I think that's pretty much it for this point, which was number 10. Okay, so we've printed the rocks. Now we want to clear the last row, which is quite simple. So for I from less than playfield, I would like to just change those to 0, like change all of the rocks to 0. After they've landed on my last row, I just want to change them to 0, which is going to mean that those cells, all of them on the last row, they are empty. So rock positions of 29 I is going to be 0. So again, this 29 here is my row, and this is my last row, and I is just the position of the column. So let me just rename this to col. Okay, let's see how we're doing so far. I don't know if this is even gonna compile, so if it doesn't, then we'll see. Okay, it does. Okay, so we have the rocks, they're falling, and we have the Z. Cool. Okay, this is very playable. I would say that this is harder than mine. I had less signs and so on. Okay, so pretty much the game works. What happens if we get hit? They go through us. Okay, this is a bug that we have to fix. So I didn't need to move that much. Okay, let's close this now. Right, so what else? We need some UI. Okay, so draw the lines, get the score done, set the difficulty as well, and after that we are pretty much done. And these are the simplest of all. Our main logic was up to here. So this last thing here that we did. Okay, so draw the vertical lines. I would like to go there. So for I want to draw them. Let me just put that paint here. I want to draw them at some position here, and all of them in a single column. So I would expect my my column to be the same, and my rows to change from 1 to whatever number of rows we have. So for I from 0 to 40, and this is going to be a column. 0 to playfield, yes, I have to get used to that. Playfield. And right. Oh yeah, this is the row. I just said that. I don't know why I changed it. Row, and I want to do this row here as well. Okay, and right. So console dot set cursor position. Again, these are gonna be exchanged. So playfield, and then comma row, and console dot foreground color equals console color dot white, and then I want to print it, of course. So console dot write is just this, just the vertical line. Okay, that's pretty much it. So then they want to draw the score, which is going to be very, very similar. Let me go back to my picture. So the score is somewhere around here. Let's do that as well. So console.set cursor position. I would like to set it to 41,3, so a little bit further on the right of my straight lines. Playfield +1, okay. And yeah, console.right line. Do I need the right line? No, just the right. Your score, and I want to put a value which is a derivation of my stopwatch that I initialized here at the very beginning, up here somewhere where I don't see it. Score, come on, there it is. So it's starting, it works. I'm just not displaying it as of this point. So let me go back down. And here I would like to say score dot elapsed milliseconds and then divided by 10. Just so that if I display the milliseconds straight up, the last digit is not really gonna matter, right? It's not gonna be very accurate anyways. And that's pretty much it for the score. And what remains is the difficulty. But right now, if I play this, it doesn't work for some reason. So the value must be greater than or equal to 0 in the console buffer size dimensions. Actual value is 30.
Row must be less than 30, not playfield. But why do you use playfield at all?
Just one second. Alright, so there was a bug. This thing here was set to playfield, which goes up to 40, and we wanted that to be just 30, which is the height that I've given up here somewhere and here as well. And right, so let's just try this. And right, so I think we are missing a red and a green as a color, but other than that is fine. And of course we still have that bug where we just don't die, which is cool. But other than that, it looks good. Sorry?
The whole thing blinks.
The whole thing blinks. Yeah, it blinks because it's very slow right now. But if I do a different difficulty, then it's gonna change. So let's do that. Let's do the difficulties, and there will be the difficulty we can set just by changing this thread.sleep value. So if I change this to 100, the game is going to be significantly faster. So and we would like to change this depending on our score. So if you hit some mark with our score, we're going to change the difficulty up to a level, which is pretty much going to mean that I have to change this value here, thread.sleep. So I'll have 3 different cases. So if score.elapsed milliseconds is less than, here I have 20 seconds, then I would like to write the difficulty at the top. So let me just where was that? I would like to have this little thing as well, to display what level are we on currently. So console dot set cursor position of playfield +1, 3. Okay, and then I want to do, sorry?
It's gonna be at the same position as the score. It's gonna be slightly lower. Needs to be slightly lower. 1. Playfield +1.
Okay, yeah, so yeah, this is playfield +3, maybe. Maybe that's what I have.
No. The 3 needs to be like 5 or 6 to be slightly below the score.
Okay, yes, you are. Yes, you are true. So yeah, this is 6. I was just looking at the line above. So console dot write difficulty there, and let me just check what we have else. Okay, and I want to have this nice effect also where if it's easy, it's gonna be in green, medium is gonna be yellow, and the other one is gonna be red. So I would like to have here console color, was it? Console dot foreground color equals console color dot green. Okay, and then console dot write, I would like to have that as easy. I am sorry, where? Oh yeah, here. Yeah, just a space here. Okay, I need a space there. And then for the easy, I would like to do thread dot sleep, and let's just say something that's gonna make it sleep a little bit longer. So 250 milliseconds, and the rest is pretty much the same except for the condition. So if score dot elapsed milliseconds is bigger than 20, and score,
it's known because you pass the first step.
maybe.
That means that it's already past 20,000. You should write it because it means the range between 20,000 and 40,000.
Let's check. Let's check. Elapsed milliseconds. Okay, so here I would like to have this to be less than 30,000, and this is pretty much going to be the same, except that I would like to have this as medium. I would like to have this color as yellow, and also I would like this to be, say, 150, I think was a nice value. Okay, and then finally I can just copy this all over, or I can do else as well, but maybe at some point I want to add more difficulty. So if this is bigger than 30,000, then difficulty is gonna be hard, and I want to do that as red, and you can just try 100. So with my game here, I've set it to 110, but we can make it a little bit harder, even to 90, to just really pump it up. Okay, that's pretty much it. And now finally we have the game over logic, which is going to be if is there collision? I can just skip that and not put that through here. And this is a variable that we had a while ago when we were checking for collision, which is somewhere here. Okay, I have this now, and I want to use it. So we want to clear the console first of all. After that, we want to just say that console right line. I would like to say game over. Couple of new lines. Your score is couple of new lines. Sorry, is space. Thank you. And I don't know, maybe something like thank you for playing. Sorry? Oh yeah, you suck, Idian. Thank you for playing. And I wanted to add something else. Yeah, you suck. I'll add that as well. Yeah, don't worry. I lost my line. Press enter to exit. So a couple of new lines. Press. Oh, I can't do that, can I? So let me just put it all here. So press enter to exit, and you suck, as per your request. Okay, I can even make it in color so that it's more visible, but I guess we'll do that a little bit later. Okay, right, and finally I would like to change this boolean variable, which was is game over. Yes, I should. Is game over equals true, and then I forgot to add the score. Was it score.milliseconds divided by 10? Score.milliseconds divided by 10. Okay, and right, so yeah, game over. I think this was my while, and at the end I want to do console dot read line, which is just gonna hold the console until I press enter, so that I can play it not only by compiling it in C#. So Control F5. Okay, this looks nice. Let's see if the difficulty works. I don't want to play for 20 seconds. Let's just say let's just change this to 10. And if you're saying that this is gonna work, I don't know. At least I believe it will be a bit strange, but let's see. So I cannot die, so there is no point of moving at all. Oh yeah, I died. How did that happen? And did not happen before? Did I mess something up? Maybe I did. Yeah, perfect. I need to set the color. Set color to red. I guess yeah, I guess here below where the game over is. So console dot set foreground color. This is gonna be console color dot white. Okay, let me try and die again, just to see why did it not happen before. So can I get hit here? Yes, I can. Okay, so it works now. Right, and that's pretty much everything about the game there is. And as the last lecture, I would like to make this code look a little bit better. And let's start with here. So this is the key handler, and this is exactly what I would put. I believe this is it. So Control RM, key handler. It does it automatically for me. Then create the rocks, which is this, Control RM. Again, Control RM, create rocks. move rocks down. I should be pressing enter after that. You must rename an identifier. What? Move rocks down. Enter. Check collisions. So maybe from here on. Check collisions. This one was short. Print dwarf. Enter. Print rocks. Ah. And okay, so this one as well. It's not gonna take that much long. So draw vertical lines, and here we have the draw score. And this is probably the longest, but then again one of the easiest methods that we have. Set difficulty, and is there collision is this one. So this is our game over logic. Okay, it works. Let us die again. Yeah, we did. Okay, and right, so now I can delete those because I don't need them. They're the same as the ones as our methods. And now the code and the whole game should be a lot easier to read and change if you want to do it. So I'll leave this. We're gonna do this in a second, and this, yeah, I'll leave that as well. Why not? Okay, so that's pretty much it. Let's check if the difficulties work. So the medium and the hard, and this is gonna be not that easy. Okay, at least the medium one does. Let's just change this value to.
Make the easy difficulty start a bit later, because there's a lot of time before the first row.
Yeah, sure. Yeah, let me just test this. So less than 15,000, less than 20,000. Let's see if I can survive for 20 seconds. Is it gonna get hard soon, please? Yeah, a bit too much maybe. So let's just change this to 110. Let's have a look. I see a space here, and then I don't know. It probably is fine. Right, so let's go through our code very quickly again. So clear the console at each step. We have our key handler. We create the rocks, move them down. After that, we check for collisions. We print it. We print our dwarf, print the rocks, clear the last row, and do some UI on the vertical lines, the score, and the set the difficulty to easy, medium, or hard, and then just check for our game over. I think it's a very sleek game, so in about 20 lines of code, if you can call it that. But it's easy to read that one, and if I want to change something, I just press, like, I go to the method and I press F12, and it's gonna take me to wherever I want to go. And that's pretty much it. Thank you.